right, so what I'm going to do today is I'm going to do section 1.3, the language of physics. This is honors physics class. This is chapter 1, section 3. So the first thing that they're doing is they're talking about a data table. So when we're talking about a data table, we're talking about when you see one, most of the time you will have your independent, your dependent variable. Remember also, when you're doing this, you have your graph, and your graph is dry, mix. Remember, that's your independent, that's your dependent. And then, of course, you have your topic, okay? So if you have, like, for distance versus time is what your units are. Now, your time is going to be seconds. Your distance is going to be meters, okay? So if you're labeling this, this would be distance in meters versus time in seconds. Remember, when you're doing this, you will need to have your units and everything. Remember, you're doing your ID, TP, independent, dependent. My independent variable is time in seconds. My dependent variable is distance in meters. Increasing, decreasing depends on what's going on the data table and the graph. And then topic, distance, meters versus time in seconds. And the purpose is we're trying to find something and we're trying to get a calculation. Okay? So when we have equations, we want to make sure that we understand different variables. So the first one I want to talk about is where you have V, which most of the time talks about velocity, which has to do with speed. We also have this funny looking E, which is called sigma, which denotes sum or total. We have a change in Y. That's what that triangle means. That means a vertical change. That means your Y-axis, that is vertical. Change is another word for delta symbol. That means a difference. And then triangle T means time elapsed. Also in your book, you have a data table. The data table that I want you to copy in your ISM book is going to be on page 25. So you have change in, and if you change in vertical position, that's going to be a change in Y. That needs to be in meters, which is M. Time interval, change in T, which has to be in seconds, and that's the symbol S. And mass is M, which is going to need to be in kilograms, which is kg. Okay, so when we're talking about a graph, if a graph has what goes up, the other variable goes up, or what's down goes down. So if your independent and dependent variable both are increasing, or your independent and dependent variable is decreasing, that is known as a direct proportional. When you're doing that, most of the time, that's going to be force equals mass times acceleration. That is known as a direct relationship. If one goes up and the other one goes down, that's known as an inverse relationship. And that is also different. So you have a direct and an inverse relationship. And you can look at those according to what your graph is saying, okay? So then the next thing we want to talk about is dimension analysis. So when we're doing dimension analysis, we are taking something to find something else. So say that I am doing length over time times length equals length squared over time. So if we look here, this here is equal, okay? So if I have 725 kilometers times 10 hours over 88 kilometers, I will actually have 8.2 hours because kilometers gets canceled and hours is what we have left. So remember, when you're doing dimension analysis, you want to make sure that you're getting what you want and what you need to do. Okay, so order of magnitude is a check answer. So if you have 10 to a third kilometer and 10 to a second kilometer per hour, that would equal 10 hours because kilometers cancel out. And so the last thing I want to talk about with dimension analysis is I want to give you a problem. So if I gave you a problem for dimension analysis, and what I asked you was this. Say that I have a car averages 20 miles for every gallon of gas. And I want to know how many years would you get? Okay, so in so many years, how many gallons would you use? So if your car averaged 20 miles to a gallon, how many gallons would be in a year? Okay, so we're going to say, all right, 10,000 miles in 1 year is what I got. But 1 gallon, I get 20 miles per gallon. So after I do the math, you should get 500 gallons per year. And that there is page 2.3, section 1.3, chapter 1, on page 23 through 27.